Rihanna. Here on time. Any question? Any question? Yes, please. One thing I have to draw your attention to is that, yes, we have regular reflection, we have irregular reflection. Being it regular reflection or irregular reflection, what you have to understand is that the laws of reflection are obeyed. Okay, so regular reflection obeys the laws of reflection, and irregular reflection also obeys the laws of reflection. In regular reflection, yes, we have a smooth surface, incident light or beam. This is more than two. So these are incident rays or beam of light. They are reflected in the same manner or pattern. Each incident and its associated reflection obey the laws of reflection. So when we pick this one, we pick the other one. Yes, normal. The same law. Okay. In all situations, the law of reflection will be obeyed. That the incident ray, the reflected ray, the normal at the point of incident all lie in the same plane or place. Then angle of incidence I equal to angle of reflection in all of them. When we look at diffuse reflection, where the surface is rough. So incident ray. Yes, here, this can be the reflection. This is the reflection. This can also be the reflection. Yes, the reflection is scattered, yet each one of them, in each one of them, we have the incident ray, the reflected ray, and when you draw a normal, in the same plane. If we pick this one, when we draw a normal, we'll have the same incident plane, incident ray, reflected ray, normal, and then angle of incidence beam. So being it rough or smooth, regular or irregular, the laws of reflection are obeyed. But the whole thing is that because of the irregular surface, the reflected rays are scattered at various angles. Please, are we okay? Are we fine?
Mr. Dia.
Hello.
Please, so see, one of the laws of reflection is that the angle of incidence is equal to the angle of reflection. But then in the case of the regular reflection, would that statement still hold since the reflected rays are different, like are dispersed, are scattered?
For irregular?
Yeah.
Yes, each one of it obeys the two rules or laws, each one. But you see, because the surface is not even, they are all scattered at different angles, but each one of it obeys the laws of reflection. Is that okay?
Yes, please.
All right.
Mr. Dia.
Hello, Deborah.
So please, the irregular one, how sometimes the rays bend, does it mean that angle of like incidence is equal to that of the reflection?
Yes, you see, the scattering of the rays is due to the irregularity of the surface. Here, because everything, the surface is even, the same area surface. Is that okay? All the light are reflected in the same manner. But here we have part of it caved in, part of the surface caving out, and so on and so forth. So this is what is responsible for the scattering nature of the rays, the irregular surface. But each one of the incident and reflected ray obey the law of reflection. Are you okay? Are you okay?
Miss Stadia, please, can
Yes,
you take a
please.
picture? Oh, no.
Eh?
I
Oh,
was asking if you take a picture of it.
oh. Then
Oh.
I've taken the picture with my duster. Don't worry, it will be drawing. So, formation of images in a plane mirror. And what is a plane mirror? What is a plane mirror? Yes, Sally. Sally,
Yes, please.
what is
Can you repeat it?
what is a plane mirror? So the question is that what is a plane mirror? Hello. Okay. While Sally is thinking about it, let's pick let me go and pick Benjita. What is a plane?
Hello.
Benjita, what's a plane mirror?
Yeah.
What's a plane mirror?
It's a material with a reflective surface.
Okay. So a reflection, a plane mirror has a plane surface coated at one end or silvered at one end. So it has a plane surface, hence that adjective, plane. Okay, it has a plane surface that is coated or silvered at one end. So if we are drawing a plane mirror, we have this straight horizontal or vertical line, plane. Then we have this ciliated lines at one end or side of it. And this ciliated line represent the coated end, coated or silvered end, or silvered end. Now, if you don't coat or silver one end, it becomes just a transparent material through which light can move. You know, a transparent material is that kind of material that can allow light to what pass through. When you coat one end of it, the coated end becomes the reflecting surface. So here, when light interacts with one end of it, it will not pass through, but it would reflect it. It would reflect it. So when you draw a straight line with a ciliated side representing the coated or the silvered end, the arrow, an arrow at one end shows the reflecting surface. Is that okay? So the arrow pointing to that end represent where reflection can occur. Please, are we fine? Okay, so let's look at how the plane mirror, okay, forms images, or how the plane mirror forms image. Now, let me draw it here. So the coated surface. If I place an object in front of it, the reflecting surface. Please, objects are always placed in front of the mirror. If you place the object at the back, what do you think will happen? If we place the object here, what do you think will happen? Yes. Yes. Any view or opinion?
I think you are not going to
No
have
image.
any reflection.
There will be no reflection.
There will be no reflection because this is the coated end. Okay, the coated surface reflect when light is placed. Okay, so here what will happen is that when you place the light, the object here, yes, light would hit it, all right, but the coat or the silver surface will just absorb it. Is that okay? All right. Now, before we look at what we do. Let me ask, how do we see? How do we see? Before you can see somebody, what is the science behind it? Can somebody help me? How do we see? Yes, Mirabel.
Yes, please.
Uh-huh.
When light falls on the person, you are able to see the person or something like that. I don't know whether the light, yes, when light falls on the person. Yeah. But I don't know whether it bounces off the person and is reflected in your eyes or something like that.
Okay. Well said. You see, as she said, we see as a result of reflection. Before I can see you, what must happen is that light from the sun or any other source of light around has to incident on you, beam on you. Then the incidented light, okay, reflects from your body and is picked by my eyes. The eyes gives it to the retina, which is our film or our chip. Your image is captured on the retina. And last time I told you that, yes, the image captured on the retina is inverted, but the interpretation is done by your brain. So we see as a result of reflection. Is that okay? That is why when there is no light and somebody is around, hardly can you see, because the light which is incidenting on the person, or when there is no light, it means no light is incidenting on you and then causing a reversal reflection into my eyes. So there is no light. When somebody brings a torchlight or candle, you have the extended light from the candle incidenting on you and then part of reflecting into my eyes. Then I can see you. So we see as a result of reflection of light from the objects we see around. Please, is that okay?
Yes.
Good. So we have this object here. Now, first rule. The first rule for image formation is that rule 1. When light ray travels perpendicular or perpendicularly from the object to the mirror, the path
Zadia.
hello,
Please, can you take a
The screen
picture
is
after?
don't worry, I'll take a shot and send it to the group. Okay.
Thank you.
So when light ray travels perpendicularly from the object to the mirror, the path of light is not deviated. So if we have light ray from the object hitting the mirror at an angle equal to 90 degrees, the path of light is not deviated. Now let me put down the second rule, then I take a shot of it. Now when light, let me use ray. When a ray hits the reflecting surface or the mirror, at any angle apart from 90 degrees, the ray deviates. So any angle apart from 90 degrees, the ray deviates. Okay, let me take a shot and send it to you, okay? I'm on Zoom, hello. I'm on Zoom. All right. Okay. So this is 1, this is 2. So these are the rules of the game now. Okay, so it's sent. Okay, so
Thank you.
we have this point source. You see, we want to trace the image formed by this. This is a point source. The object is just a point. Okay. So this is image. Oh, let me change my mark. This is image from a point source. Meaning this object, this is the object. It's just a point or a dot, okay? Just a dot. And we want to see how the image can be formed when placed in front of a mirror. The first thing is that, the first rule is that draw a ray coming from the object which is perpendicularly to the mirror. So once the ray hits the mirror at an angle of 90, the first rule is that when light ray travels perpendicularly from the object to the mirror, the path of light is not deviated. So the path will never be deviated or bent. It will go straight. Okay, now we all understand that, you see, for an image formed in a plane mirror is said that the distance of the object from the mirror is the same as the distance from the mirror to the image. So if this from the object to the mirror is x, then I have to measure the same distance from here to here, the same magnitude x, to give me the image. Okay. 2, I can also have a ray of light hitting the mirror at an angle theta. So I can have another ray hitting from the object, hitting the mirror at an angle. Okay, now the reflected ray, once it hits the reflecting surface, there will be deviation. The path of light will deviate. So this becomes the reflected ray. And when I draw a normal, angle of incidence must be the same as the angle of reflection. But when I extend the path of the reflected ray, it has to meet the other ray. And whenever two or more reflected, the point where two or more reflected rays meet or appear to be meeting, okay, is the location where an image will be formed. Please, is that okay? I can also draw another ray from the object, hitting the mirror at an angle, so on theta. Now, when I trace the reflected, once it hits the reflecting surface, we have a reflection. Now, when I trace the reflected ray at the other side of the mirror, it has to meet all the points. And this is where the image of this object in front of the mirror will be formed. So basically, we need just two or more reflected rays to give us a location for an image. Here, how many rays did we use? We used this one, 2, 3. So we use 1, 2, 3 rays to form this. But in fact, you can just simply use 2 rays to form an image. All right, you don't have to go beyond maybe 3. When you do that, it's like you are littering your diagram with rays. So this is how an image of a point source can be formed. Please, any question?
Mr. Davis, can you go over
Can
again?
you have the picture of the
Okay. All right, let me first send the picture. We will look at an extended source, and the extended